Well, hello everyone. Welcome to this webinar on showing some of the new and improved features in Carlson Hydrology 2014 and our new module called Carlson Trench. My name is Mark Long, and I'm joined today by Todd Carlson and Karen Cummings.
Hi everyone.
Both with Carlson Software. So to begin with, I'm going to show you some of the new improvements in the Carlson 2014 hydrology, and then Todd is going to go ahead and show our new trench module. If time permits, we'll take questions as we go along or at the end. Please feel free to type them into the webinar chat box there. And so let me go ahead and just get started. What we've got quite a few new improvements in the 14 version in hydrology, so I'm going to go ahead and switch over to the hydrology menu here. And sometimes it's the little things that make things really good, and so one of the little things that I want to show you to start off with is the ability in our rainfall libraries. We have the ability now, if we select new, and let's just go with rainfall intensity lookup table. Now we have the ability to add the one-year storm and also a user-defined storm event, which may be for your historical storms or other such things that you have to, run the program with. So, we also have done. If I click OK, well, let me cancel this and go to now edit one of mine. We've also added in the ability to reset return periods down here on the dialog box. So by selecting reset return periods, we can add in now the multiple different ones at this time, and you can enter the data for each of those as you see fit. So that's one of the very small, but very many users have asked for this, and so we have added that into the program. And I can cancel that. The next thing I would like to show you guys is our new. We've gone through and redone our lateral design feature. So if we go under the network menu, you can see we've added a new menu here for the laterals themselves to create lateral structures. So I'm going to just go in here and zoom in here, and we'll just do some of these. If I go, we'll start right here. Just pick somewhere here in the middle. Network, laterals, create a lateral structure. What happens is you're prompted here with a box that says you can pick a structure if you want to connect into a manhole or a box culvert or box structure or whatever you want to do. And you can also pick a pipe. I'll pick pipe, and then I'm going to use my snap option here to do at a parent intersection just for this. And you can see that I've made a connection into the sanitary sewer line for my lateral structure. Now we have changed the interface to be more modern to these button menus, and you'll see that within RoadNet. You'll see that within the dialog box of the of storm drainage and things like that. So it takes a little getting used to, but it's not too bad once you get the hang of it. And so I will click here now. I've added a connection, and within this dialog box we can give it a name. It looks very similar to the dialog box of the sewer network or storm network. One of the major differences is down here you can change the connection height of this. So typically I come into the top of my sanitary, and we have a saddle and lateral and do all that stuff. So I'm going to just put 0.83 for 10 inches above the invert for this. And I'll come over and just let it update. And then I'll add a clean out, and I'm just going to pick a point and just select this, get my snap in, the endpoint here. And it's going to tell me that it's going to connect to CN1, and it's going to be the length of the pipe is here. Update, and it's correct. Now, typically what I would do is probably come up here and change this clean out name to 135 for the lot number itself and save. And basically then you now have your pipe tab just like normal. I would come in here and set this to PVC, set it to a 6-inch pipe. and you can see that you have invert information and that you can adjust here as well. You also have values down here that you're able to adjust for lateral riser station, riser height, slope ratio, and other things down here in the bottom that you can adjust. And you can also see in our pipe profile that it's now drawn my service in here, and you can see that I've got an RCP crossing that is happening here, and it's showing you that in the profile option here. So now we can go back in. If we hit save and it updates, you'll see that the pipe sizes went down to the 6-inch, and I've got my connection, things like that. To do it again, add a connection, pick a pipe. I'm going to go ahead and snap to a parent intersection here. Do this like so. And my next connection has been placed in. You can again set the connection height if you want to. This one I'll bring into the center of the pipe. So I think that's I think it's 0.167, something like that. And we'll go ahead and update and add our clean out. Pick a point, pick on the corner. Tells us that. Update plane view labels, and now you can see that I've added in my next clean out. I would again change it just to keep it consistent to lot 27 and save. And now you can see that that profile, I don't have storm drainage on this side of the road, and you can see the pipe and all that good stuff. It's very simple and very easy to do. You know, if I exit this, there's certain options as well that under your network setup, sewer network settings, we've added a new tab here for our laterals, and it basically states that you can set minimum and maximum slopes, your normal slope. You can also specify whether when you make changes to the main line that you're able to hold the lateral slopes, you know, where if you need to maintain a 1% slope for your clean out, or if you want to hold the slope of the lateral pipe connected to the main line, or hold lateral inverts at the clean out location. You can select your symbols for the connection, and you can also have it how it's going to initially name your clean outs for you. CO for the clean out, CN for the connection, and I usually just kind of, you know, change those in the dialog box as I go. So I can hit cancel there, and now I can show you that hold on. I can show you that also we have the options in your draw sewer in the plan view as well. I think that's not what I wanted. I want to go to draw sewer network, plan view label settings. I'm sorry, I apologize. We've also added in the lateral labels here as well. Now here you can specify whether or not you want to draw the laterals. One thing to keep in mind is that the laterals are part of your sewer network. So, you know, there's many ways that you can handle whether or not you want to draw these as such. I choose to do mine with layer control. So down here at the bottom, I place my label text on P lateral text, and my laterals in the line work will all be on laterals. You also have the option up here of to draw the laterals or not, to label them or not, how you want to see them with just a 2D, a 3D, double width and width. Pretty much a lot of the same pipe options that you have with your regular network. You also have the parallel leader. You can label the cleanout name. If you check the box, you can also label the connection name, and so on. Pipe lengths, size, slopes, you know, and the other information that you may want to label with your services. Also, since, you know, now that we put in these two laterals, I want to show you that they also, in the spreadsheet sewer editor, we're able to go ahead and see these laterals now, how I drew them. with the sanitary in relation. And remember, the one that I set on top 10 inches above the invert, and the other one I thought I was going to hit the center, but I kind of missed it a little bit with my offset connection. But you can see those now, and you also can see the other pipe crossings and such in this editor. If you select the new checkbox here, edit lateral lines, now you're able to see these in more of the spreadsheet type of scenario and change them accordingly. You can see that by switching each one. I'm just toggling through each one, which is a pretty new and nice feature that we've added. The next thing that we can also have added in the option to use our report editor to also report our laterals. So coming into Report Sewer Network, you can now see we've added in the option for report laterals as well. And you can select and report whatever whatever you would like to have in your report. The lateral slopes, materials, shapes, sizes, Manning's in, everything that you can associate with this service, and clean out and do it within the display, the spreadsheet viewer, a table entity to bring into your drawing if you see fit. And we've added a lot of enhancement features into this report formatter for several different options that I want to show you today. So one of the next things, and close that report area, is that we've also added in a new pipe connection wizard to help you when you are inserting pipes into your projects. I'm just going to go up here to the top to get away from all that mess and show you what I have going on. Is that if we come into Network and we create a new structure, I'm going to use a pick option. So the thing that's going to pop up here if I pick is this new connection wizard. Now we could add a structure only, but I'm going to tell you, if you have your auto connect features on, that is going to it's going to prompt you, or it's going to try to auto connect. So it's not just going to put the structure only. So typically all of those features I leave on prompt anyway, and so that it will prompt me. But we've also have this new one that's route piped through the new structure, which I'm going to show you right now. So if I select that, it's going to go in, and I'm going to update my sewer labels. And now you can see that manhole 25 has been added to my sewer network, and the pipe has been routed through the new manhole. Also, if you add them here, you will still get let's pick one down here, and the wizard will pop up again. Here, if I wanted to only add structure only, I can select structure only, but since my auto connect feature is on, it's prompting me, do you want to connect to the closest manhole, which is 9? I'm going to say no, and then I can update my sewer network again. Give it just a second. And so now you can see that the new manhole has been added out here by itself, and it's not part of the existing run. And then I will show you the last one, pick point, and I'm just going to say midpoint there, and then insert structure along the pipe run. So we select that, and it will basically place a manhole in line between the other two that are on each end. So those are new features and nice features that we've added into the program as well, to help folks with the connections of manholes and things like that. There's a lot of requests for that type of stuff. We've also kind of gone in, and while I'm on pipes, we've also gone into the, and I'm going to exit this. Changes. I won't say many changes. We've also gone into the civil menu itself, and I'll show you that if I go to civil, we've also added a feature here that you are able to easily kind of draft pipes and storm systems, sanitary systems, or whatever the case may be, by selecting this Input Edit Sewer Pipe Profile. I'm going to do a new, and I'll call this webinar, and just overwrite my old one. So basically what you do here is that you're able to input just basically a profile itself, and you can see the little diagram down at the bottom that kind of explains what the invert in, invert out, the step up means, the sump as well, and you're able to kind of draft profiles very easily using this. So just to show you guys how it would work, I'm going to go ahead and make this, we'll just make it manhole 1, station 10 plus 00. Invert out is, or invert in, let's say 100.2, invert out 100. I'm not going to put a sump in. You certainly can if you want to here where I'm located at. We don't use those too often. Your manhole invert, the rim elevation, we'll just make it 105. And you basically enter in your manhole information on line 1 and 3. And then the middle line will only refer to the pipe length, slopes, and some of those options get filled in for you. So we can go manhole 2, say 1100. We'll make this 99.2 and 99. And you can see some of the other options are automatically starting to get filled in for you. The step up and the inverts, your rim elevation will make it 104. Now you can also change here by going in and just saying an 8-inch, and let's say your wall thickness is 0.21, and you can keep going. Manhole 3, 1200, 98.2, 98, and again, most of the other stuff starts to take care of itself, or you can input this other information and other things take care of itself. My rim elevation will go 103, and now these values that I had selected before are still being used. You can save this, exit this, come back up here to draw a profile, and it's already selected, so I'm just going to say OK. You have your settings. There are some new, probably some new feature for lateral connection labels here as well, where you can label in your profile how those laterals are going to show up, you know, and things like that as well. But I'm going to say OK. Say OK. Come out here off to the side, and we'll just draw a profile. And you can see now that the information that we put in is now here in just this little profile, very quick and easy to help folks. You know, you have all your settings just the same as in the past. So that's one other new feature that we've added. Another thing that we've added in here as well is we have a new collision conflict check that is going to give you much more flexibility and freedom than what we had before. Going back to the hydrology menu and coming down to check sewer network, we can come in and look at our collision conflicts. Now, what we've done here is, you know, I think in the 13 version we were only able to select 4 different SEW files. Now we have the ability to check multiples by coming down here, and you can say add file, and you can select the ones that you would like to check. And here I'm just going to add a couple, and I'll do, let's see, sand sewer. And so this is my storm drainage and my sanitary sewer file. We can also come in here. We could remove files if we want to. We can use the collision navigator. We're also going to draw collision symbols and our crossing symbols, which you can set up based on what symbol you want and the layer that you want to put them on and things like that. But also in here, like I was telling you a little earlier about the report editor, we're also able to do things like that here much easier. So now we can come in here and specify in our report editor the the pipes themselves, the upper pipe system, the lower pipe system, the crown, the invert of each crossing if we want to distance and our overlap and things like that. So you have a whole lot more flexibility here than in the past. And you know, and once again, just displaying them, using a table entity to bring them into your drawing, things like that. I use this quite a bit because I like to keep all of my information associated in my drawing, and you know, for dirt quantities or other things, so I keep a date associated with when I check this dirt quantity and other things, and they're always located somewhere in my drawings. But you have a, you know, much more flexibility, and same thing with report collision. The systems, you have northing, easting, elevation overlaps, things that you can just double click and add over into the column, or you could select them and add here. I typically just double click and go on about my business. So we have, you know, that new feature as well. And if I just hit OK here, it's going to tell me that. Now, when I did this design, I intentionally had collisions to show up because basically I set my sanitary 8 feet deep, my storm was about 5 feet deep, and I wanted to make sure I had collisions to show. So you can come in here and see and zoom in to the actual collisions themselves. Let's zoom in. And you can see that, well, that's kind of a big pipe, so it's very difficult to see. Let me go to another one here. And now you can see underneath here, zooming in, you can see these symbols that are underneath, basically showing where I've got crossings, where I've got collisions, and other things like that. You know, so that's another new feature that we've gotten added into the program for you guys. Also, I know I want to take as many questions as I can from you guys, but I'm trying to show you so much that, you know, there's a lot of things going on. You know, we have a new feature for our ponds that I want to show you really quick. If we go, and I'll zoom down here to where I've kind of got a pond located for this project, and I can go in here into my structure and design a bench pond. And the new stuff that we have here is, you know, of course, a lot of it looks the same. There's surface file for our model, our design ratio or slope format, typically using ratio. But what we've added is the bottom surface of the pond. Now, you know, you're able to input an actual elevation for the bottom of your pond, a sloped surface if you want to now, the original surface, and also select a surface file. And I'm going to show you how to just select the surface file to show you how it works. We've got other things down here, just some, you know, cut and fill and things like that, top of dam width. Most of this stuff is pretty much the same as it was. So I'm going to select OK, and it asks me to pick my top of my pond polyline, and I'm just going to select that. It's asking me for my existing surface. I'm going to select him, and now it's asking me at the command prompt down here, what are my slope ratios? I'm going to just go with 2 to 1, 2 to 1. I think the interior slope of this pond will go 2 to 1 too. And it's also saying that the top of bank elevation is going to be, it's looking at the existing ground surface and giving you a rough idea here. And I'm going to say probably 338 is what I would use. And now it's looking for the interior surface, which is again, our existing ground surface is what we're going to use. So I would select EG again, and you can see that it's gone through and now created my pond for me based on this existing ground surface, and I'm going to show you what it looks like when I draw the contours. I can specify my stage storage, automatic. It'll prompt it, come up and give us our stage storage information here. If I want to adjust the perimeters and redesign, I'm going to say no. Write a stage storage file, no, not at this time. Now I'm not going to write a final surface, but I am going to let it contour this pond. We'll just use this default stuff here that we have here. And you can see that now it's used the bottom existing surface, and these contours are matching the bottom of the existing surface, and we've gone in and created our pond. You know, that's a very nice feature. as well. Now, you know, I'm going to show you again how we've also added in a new module that called Trench. And I'm got really excited when I was talking with Todd about it the other day, because there was some things in there that I really wished I'd had when I was in engineering private design. And I want to show you that before I do turn it over to Todd, and show you kind of how this works down here. I think I have a network here that I want to show you that I put together. Let me change this down to Trench and say OK, and I'm going to draw my sewer network into plan view. And so you see I basically added just a pipe run down here to this existing manhole that I have, and I just ran a 400-foot length up here just to show you guys. At this point, I switch over to this the new Trench module, and I would come in here and I would select the Trench network backup file, and I'm going to load my network. So I'll come down here, select my sewer file, and that's basically really all I have to do, and I can come in here and get my Trench network quantities. I'm going to let Todd show you how to create a template. If you want to see the template for this, I can show you. Let me cancel this, and I'll show you my Trench. Let's see here. Todd, where do I find that?
Yeah, it's about 2/3 down. Input edit Trench template.
There we go. Yeah, I'm sorry. It's kind of new to me. So basically what I've done here is I've created a Trench template, and I have, you know, I don't have a bottom offset, although I certainly could if I wanted to put in 0.5, and so, you know, if you have special bedding that you need to put below in your trench or whatever the case may be. My trench width is 1.5 feet or 18 inches based on, you know, including pipe width. My slope format, again, I'm ratio. The display sewer structures is pipe. Add pipe diameter to trench width. Yes, I do that. And so then you can see down here at the bottom that I've added in some backfill quantities as well. I've selected suitable fill material backfill at 3.3 feet, and also number 57 stone right above it. Which was basically my trench was looking at is if you were replacing it with asphalt. And that's how I created my. You can also, and Todd will show you a little bit more about this, edit your benches so that you know, you can bench your trench as well. And Todd will show you a little bit more of that when he shows his stuff. And so I'm just going to say exit. I'm going to say yes. I'll just save it. Come down here, the Trench network quantities, and I have, you know, you can use the report formatter here. You can have it report your backfill volumes, calculate cut volumes, and things like that. I'm going to select my main template, which is the one I just showed you. My target surface, I've had mine set to just rim elevations. You can set it to multiple different things. And the target depth is pipe bottom. And then I'm going to have it report my manhole depth summary. This is the feature that really got me wowed, and report the structures and things like that. So if I hit OK, I don't have pipe groups set for my pipes, but now you can see the trench quantities there, and also the amount of stone, also the depths and things like that. And that's one of those things that got me. I was like, wow, that's a good thing, because I've done this many times in the past where I've had to go in here and calculate how much of my sewer run is between 8 to 10 feet deep, or 6 to 8 feet deep, and also 0 to 6 foot deep, 6 foot depth. And if I isolate these to show you, so now you can see that it basically goes in and draws polylines where you can select width, the lengths of how much is between 0 to 6 feet, how much is between 6 to 8 feet, and those depth and those quantities for your takeoff quantities. That was, I wish I'd have had this a long time ago. I can tell you that. because, you know, going in and measuring it off profiles and doing things like that, it takes quite a bit of time, whereas this program spit it out very, very quickly and very easily. So, you know, with that being said, I do want to pass this over to Todd, but I would also like to see if there's any questions that or anything that I can help you guys or answer, if you have anything. I'm not sure if Karen is probably taking most of the questions.
There's actually only one question, and it comes, oh, there's another one. But the first question came early in your talk from Gary Rosen, who works at Carlson. And his question is, I'm not sure I understand why, when it asked to pick a pipe, you had to do an apparent intersection OSNAP.
Scott, you don't. You can just pick the pipe anywhere you want to, but I'm a 90-degree kind of guy, and so typically what I do is I will, you know, try to keep my surfaces everything parallel and perpendicular to my pipes. That's the only reason. There's no other reason whatsoever. You can pick that pipe polyline and go on about your business.
And then we have another question: can trench width be based on pipe size?
You can basically, and I think Todd probably get to some of this in just a minute. You can. I basically created my trench to add 18 inches on each side of the pipe. So as the pipe size increases, that trench width increases 18 inches on both sides. I think that.
Okay, that's all the questions.
That's good. That's good. You know, there's a lot of features in here, and there's quite a few, but these are some of the main ones that I wanted to touch base on to show you guys. And so with that, you know, I'm going to go ahead and turn this over to Todd.
Okay. Thank you, Mark. That was great. A lot of stuff I hadn't seen yet. It looks good. Let me show my screen now. And are you seeing that, Mark?
I do.
Okay. So we got a different job here, and I really wanted to show two things. One, taking a look at that the trench quantities report that Mark did and some other options in there. And then I'm going to show how you can create that report if you're not using hydrology and creating your sewer networks through hydrology, how you could do it just from plan view labels that you might have in a drawing. So I've already ran one report on this, and I just wanted to look at these quantities. So we could see the dimensions of our trench here. And then what Mark showed is that we have a total cut volume, and then we have a backfill volume. So I can see the total cut for my trench run here, and I can see the backfill volume is different because I have, it's less than the total cut because it's taking into account the size of the pipe. So it excludes the size of the pipe from the backfill quantity, and then it also breaks up based on your trench template the backfill quantities. Okay, so I can see that there, and I can see my total cut. This total cut right now is based off of rim elevations. So I'm going to create an existing design surface, and we can see, instead of just using the rim elevations, how if we use an actual 3D model to calculate our volumes, how we can get a more accurate total cut volume. Another thing that Mark touched upon is in the plan view, it labeled where on the drawing how deep that trench is. So I could see where 0 to 4, 4 to 6, 6 to 8, and we'll look at where you set these up and define it. And then in our report here, along with showing it in the plan view, you also get a list of how the linear footage of trench and how deep that is. Another thing you have is the pipe size. So based on the pipe sizes in your sewer network file, you get a linear footage broken down for those as well, okay, and the depth of manhole. So let's look at trying to get a more accurate total cut volume. do that, or to look at it a bit more, I have a profile of my trench here. So based off of just rim elevations, we're calculating volumes. But if we have existing conditions and design conditions, we can use those as well. If we use just existing and we calculated our trench cut, we would get quantities, cut quantities from the bottom of our trench all the way up to existing. What we have in our software is being able to look at minimizing the cut based off of two surfaces. So if this is the design surface, I'm cutting down to here to the design anyways. So in calculating just my trench cut, I really want to use the design surface to the bottom of trench for my cut quantities. And then in places where I'm actually in fill, I'm not going to build up to the design and then cut in the trench. I want to calculate my trench cut from this existing surface. So let's look at how we can do that. And we can do that using our Civil SiteNet program. So within Civil and SiteNet, and this is takeoff in construction, is that we first define layers for existing and design. Okay, so the SiteNet building models through SiteNet looks at all the layers you have in the drawing, and you tell the program which ones are existing and design. And by having these lists of existing and design, it gives me two things. The first thing is it gives me a nice layer control. So if I hover over these, this says display existing drawing, display design, and display other. So I can toggle off the design and other, and now I'm looking at just the layers. If I turn on my drawing inspector, see. Okay, so these are my existing points. All right, and that's from this list here, existing. If I turn off existing and look at just the design, now I can see the layers set for design. So I get a nice way to toggle between those, that line work. And what I can do is that this line work is in 3D. So I can build models based off of these lists of what's existing design. And to do that under SiteNet, is I just say make existing ground surface and make design surface. So it's just looking at those layers. It's looking at, for the design here, it's looking at the 3D aspects of these contours and building pads, and it's going to create a 3D model for this. And all I have to do is pick this icon, and it creates a tin model for me. If I want to view that tin model, I can click on Surface here and say, show me that design surface. So those layers are defined as design. Okay, so now I have an existing surface. If I run the command, I also have existing. So I have existing design. Now I want to use these two surfaces that I've created through SiteNet to get more accurate quantities on my trench. So let me just first display last report, and I'm going to put this on the screen. Okay, and we're going to see how these numbers change by using surface models instead of just rim elevations. So I'm going to go back into trench now, and I'm going to say trench, calculate trench network quantities. Okay, and then instead of using the target surface as the rim elevations, let's first look at if we just use the existing. So I'm calculating from the existing surface, the existing conditions, to the bottom of my trench. Okay, and you can see my total cut has increased significantly. So almost 700 cubic yards of cut I'll put this to the screen. Okay. Before it was 470 cubic yards. So I've increased that almost 50% by using the existing surface versus the rim elevations. If I run calculate trench quantities again, let's do the minimum of existing design. So if this is a cut scenario, it's going to use the design surface to calculate the trench cut. If it's overall a fill area, it's going to look at the existing surface to calculate the trench cut. I'm going to say OK here. Okay, and you can see it reduced this. It's lower than the rim elevations. So if the site is in fill, I can actually have less cut than if I calculated them off the rim elevations. And then I can see I have new backfill quantities. So by using a surface model, I can get a really accurate number of the cut that's involved in putting in this trench. And I can put this to the screen as well. Okay. If we look at this job, okay, I'm going to turn on the other drawing, which has my trench in here. So you saw we had backfill quantities of sand and stone. That's great for areas of the road, for areas of my trench that are in grass, but I might want different backfill quantities if my trench is inside of the road. So maybe I have to use a select fill that's inside the road here. So under trench, we have input edit trench template. And let's load one that I've created for the road. Okay, so I have stone going in here, and you see I have it defined as a foot. Okay, and then I also have add pipe diameter to backfill thickness. So the bottom of my trench is 0.5, and then it's adding that pipe diameter to this backfill of stone. So I have another 0.5 of cover over my pipe. So as my pipe gets larger, if it goes from 12 to 18 inch, I'm always going to have a minimum of half a foot of stone on top of that pipe. That's what I want. And the question earlier, add pipe diameter to trench width. So add pipe diameter to backfill thickness controls the backfill amount that I want above the pipe. Add pipe diameter to trench width. What that does is it looks at this trench width of 4 feet, and then it takes that number, and it's basically 2 feet to each side of the pipe. So as the pipe goes from 12 inch to 18 inch, I'm holding those 2 feet on each side of the trench. So my trench gets wider as the diameter of my pipe gets wider as well. Okay, so those are toggles. I don't have to do that. So this is a straight 4 feet across. As my pipe gets bigger now, my trench won't get wider. But by clicking this, that ties those together. Okay, and then what I have defined here is a select fill. So I'm saying, you know, maybe I have a road here, so I can't just have regular backfill. I want at least 3 feet of a select good fill to go on top of it. So I have these values set as 1 foot and 3 foot, and then depending on the depth of the trench, this backfill quantity will vary. Okay, so let me do save and exit. And let's set that up in our report. Let's do trench network quantities. And now I'm going to do, I have my main template, and then I have a subgrade template. So in order to use a subgrade template, I need to define in the plan view where I want to use that. So before running this, let's go to trench, and under trench we have trench subgrade areas. I'm going to do set trench subgrade polyline. Okay, and now it selects objects. So my road, I need a closed line that defines the area. I have one here for my road, so I'm just going to pick that. And I'm not doing any exclusion. So if I go to trench subgrade areas and hatch those areas, okay, I can see for my trench, where is it going to use that subgrade, and where is it going to use the main template. So most of this looks like it's inside of my road. When we enter this one in manually, I'll have more of the main template. But when it's crossing the road, it's going to use those different backfill quantities that I defined. So I'm going to go to trench and just erase that hatching. Okay. So if I go to trench network quantities, and I say I have my main template set, I'm going to say subgrade template, and I'm going to load that second one and say OK. Okay, so I can see, I can check the dimensions of those trenches, and then I see trench dimensions for subgrade. And now I can see a volume for that select fill versus the stone and sand, which is varying. Okay, so it didn't change my total backfill. It just changed the different materials that make up that total. Okay, and I can see, I can confirm here the linear footage of trench inside that subgrade template, and the one that has that's in the main template. Let's look at the cut volumes a little further. So I get the cut volume there, but if I look at this job, I can see that there's boring data on here, and this is kind of the power in our software is in coming from takeoff, the ability to use SiteNet with trench here, and also a geotech report. And I'm going to put in some borehole information, and it will change my cut volume from just showing a total cut to how much of that is rock. So if I look at this drill hole right here, I can see the rock elevations at 357.8. I can see that is that's below my invert out here. So I really shouldn't have any rock cut here. But if I look over here, I can see my invert out is 354, and my rock is 14 feet, 15 feet above that. So of my cut, I can get how much of that is actually rock. And we do that through the geotech module. And it's pretty straightforward. There's really three things you need to do. Define drill holes is the first one. So I have dirt and rock. Okay, I already have, if this is where you'd set up whatever strata there is on the job. So I could add clay. I could have an unlimited amount of different types of strata that are on this job. We're just going to use two, dirt and rock. And then after setting those up, I would do place drill holes. So I could type in the coordinate, or if it's labeled in the plan view, I could just click on that location, and then I'm prompted for the dirt thickness, which I'll say is 4. Okay, so this picks up the existing surface, and it's dropping down, it's creating surfaces or drill hole elevations for the dirt and rock. Okay, so I've entered that in. I've already added about 5 other ones throughout the site. After you've entered in all your drill holes, you go to Strata Calc and say Make Strata Surfaces. So there's different modeling methods of how it's going to try to create these, but it's basically looking at all your drill hole information and the existing surface, and it creates underground strata for that. So I have two strata. If I look at a strata cut color map for the rock, this is rock versus just the design. So this is looking at a rock strata model versus the design. I can see I have a cut here. With the trench, I'm going to get even more cut in this area. So with those surfaces, strata surfaces created, if I go back to trench, I go to trench network quantities. Okay, now that I've created those, I have the option to use Strata Profile. So I have the dirt or rock. I want it to look at the rock strata model that I've used. And I'm going to say OK. Okay, so now my total cut is broken down looking at that strata model for the rock. I get a volume of that and a volume of the overall cut, which is big. You know, it could be 5 times more expensive to remove rock versus some other material. And I know, I can't use this as a backfill back into the job. I only have this that could be used as backfill. So this is big for determining the cost of my trench. Let's look at these zone depths, just where those are set up. In my report, there's setup depth zones. Okay, so this is customizable. Up to 10 different zones, you can get a breakdown of the job. So this reports out the linear footage of the trench at these different depths. Okay, so you can set these up to any way that you want or need to report them. This shows them in the report. And then to draw them on the screen like Mark had, there's Draw Plan View Zone Map. So if I go to the setup for this, it's just going to draw these on the screen. Okay, one thing that's cool that we've added for 2014 is that I can draw this trench in 3D. And I'm just going to call this 3D trench. So let's do those two things. All right, I'm going to say OK. Okay, you can see that my zones have changed now, so I get a different breakup with the linear footage. Okay, so now I've drawn a little legend, and it's drawn those values, labeled those on the screen here. As Mark showed, I can see yellow and green. I can see what depths those are at right on the screen. And then it's created this 3D line work. So if we look at that, let me just isolate that layer. And let's look at the design contours too, the buildings. Okay. If I look at this trench in 3D now, it's created 3D faces for my trench. I zoom in here. Okay. See, my trench is in 3D. You can see where it's benching a little bit before it's sloping back. So that's cutting in the trench, and then I see the pipe in 3D as well. Okay, I have a 12-inch pipe coming in here, and it's transitioning to an 18-inch pipe afterwards. So I can see that there's a larger pipe there. And that's, you know, if you have hydrology and you're building these sewer network files, then as Mark showed, you're just loading that sewer network file in trench, and then you can go to trench network quantities, and there's drawing it in 3D, drawing the zone map, doing multiple templates, calculating the volumes using different surfaces, using profiles. So just this one command gives you a lot of information. Karen, are there any questions at this point?
No, there haven't been any questions since the trench width one.
Okay. I'm going to show. I'm going to show just if you don't have the, if you're not building those sewer network files that you can just load. If you just have it in the plan view, I'm just going to quickly show entering in that information through trench. Under our trench pull down, there's input edit trench line. Okay, so I have a polyline that represents where my trench run is. If I had just points, I could pick points. And I'm going to say OK to the rest of the defaults. Actually, I'm given a rim elevation, so I'm not going to default to a surface. Just going to say OK. Okay, and then I pick on this line, and starting station 0. Okay, and now it's jumping to what's the manhole ID here. So I can either enter in this text, or if it's text value, I can just pick it on the screen. Okay, I can see it's read that value M10. Now it prompts me for the invert in and the invert out, and then the rim elevation, which I'm going to do S for select, and I'm going to pick on that rim elevation. Okay, it jumps to the next structure, and I'm going to just pick on these as I'm getting prompted down here. So here's the invert in, invert out, and rim elevation. The pipe size between those, let's do 12-inch. And then this last one, I'll just show, if you do E for enter, if you can't pick on the text, then you can just type it in. So I'm typing in these values, M7. The invert in will do 375.8, and the invert out will do enter 375.8. And then the rim elevation is 380.8. Okay, and we'll do a pipe size of 18. Okay, and now it prompts me to do another line, no. Okay, so if you're looking just to do quantities, and you just have information labeled on the screen, you can type in those values, and you're basically creating your own file of the trench information, and I can go up here to trench, edit trench network structure, and I can see this structure is connected to M7. I can see the rim elevation, the invert out, and invert in, so, and the slope. So if I typed anything incorrectly, I could edit it here. So let's do, the invert out here is 360. And if I go to next, it jumps to that next structure, M10. I can see which one it's connected to, and that same information. So once I have that in the program, okay, and my trench template, So this is something, you can build a library of these. This is an external TCH file. So you can load these on different jobs. It's kind of a one-time setup. If I go to trench network quantities now, okay, instead of, I could calculate all the trenches. Let's just do the one I just entered in. So I entered this one in manually from the screen. This other one, I had a sewer network file, so I just loaded that sewer network file. I'm not going to draw this one in 3D, but let's say OK. Okay, so now for this run, I can see the linear footage, the pipe sizes, and of my cut, it's mostly rock here, and most of it is I'm using that main template, not my subgrade template in the road. So you can see I have less select fill for that. And that's kind of a brief intro of how you could use trench with hydrology, or if you don't have hydrology, entering in the information with input trench line. And that's all I had to show, and I went 2 minutes over.
Thanks, Todd. That was awesome.
Any questions, Karen? Anything you'd like to add?
No, there are no more questions. I just say thank everybody, and you'll get information on next week's webinar.
Okay. Thanks, Karen. Thanks, Mark.
Thank you.
Thanks, everyone, for stopping by.
Thanks, everyone.